Welcome back to Mr. Vaughn's classroom, where math is made easy. Before we get started on this video, I'd like to ask you to please hit that subscribe button, give this video a thumbs up, and engage with a comment below. In this video, we're looking at Unit 1 on constructions and rigid transformations, Lesson 18, practicing point-by-point transformations. The learning goal for this lesson says let's figure out some transformations. We do have two learning targets in this lesson. Once we get done with the practice problems, we'll come back, review these learning targets just to make sure you understand everything you need to from this lesson before moving on to the next one. So learning target number 1 says that given a figure and the description of a transformation, I can draw the figure's image after the transformation. So simply put, if they give you an original figure and they describe the transformations that they want you to do, can you draw that image that results after doing those transformations? And learning target number 2, I can describe a transformation that takes given points to another set of given points. So in this one, if they give you the original and they give you the image, can you describe which transformations happened in order to go from the original to the image? We have several glossary terms again. The first one is assertion. This is simply you making a statement that you believe is true, but you haven't yet gone through the steps of proving that it's true. Next, we have congruent. Shapes are congruent if there is a sequence of rigid transformations that can take you from one shape to the next. So those rigid transformations being translations, rotations, and reflections. So what you end up with is a shape that still has the same side lengths and still has the same angles, because you didn't make it any bigger or smaller and you didn't change the shape. You just moved it using those 3 rigid transformations. Directed line segment. This is just like a line segment. It does have the 2 endpoints, but you now add an arrow that shows you which direction it's moving. So instead of this simply being a line segment AB, we now know this is a directed line segment that is taking A to B. When we talk about image, we're talking about the figure that is created by doing the transformations. So in this example, the bottom left triangle ABC would be the original, and then it is translated up and to the right, creating the image A prime, B prime, C prime. Line of symmetry means a line where you can reflect what is on one side of the line across that line of symmetry to the other side, and the figures will line up perfectly. So on the left, we're going to take that regular hexagon, fold it in half to the right, and the lines will match up exactly. In the middle, we're folding it kind of diagonally, but again, those lines will fold over right on top of each other. And then with the capital letter I on the right, you could fold that left to right, and the lines would match up. You could fold that top and bottom, and the lines would match up. Reflection. This is where you're going to reflect across a line. So you're not folding the shape on itself, like with symmetry. You're now going across. You're reflecting across that line. So in this case, that line of reflection is M. We reflect A across M, and we get A prime. Reflection symmetry. We say that a shape has reflection symmetry if you can reflect across a line and reflect it onto itself. So in this case, this X shape that we have, you could reflect the top on the bottom or the bottom on the top, and the lines would match up perfectly. You could reflect the left onto the right or the right onto the left, and again, those lines would match up perfectly. Since you can reflect it across a line onto itself, we say that it has reflection symmetry. Rigid transformation. These are the three movements that we've talked about: translations, rotations, and reflections. And we can even talk about a sequence of them as being a rigid transformation. So in this example, to go from A to B, we translate down and left. To rotate from B to C, and then reflect from C to D. Rotation. You need a center to rotate around. You can rotate clockwise or counterclockwise, and then you'll end up with an original point, an image point, and they'll have the same radii. So on the left, we have O at the center. We have P rotating counterclockwise t degrees, and it creates the image P prime. On the bottom right there, we have two quadrilaterals. Point D is our center point that they're rotating around. ABCD is the original. It rotates 120 degrees counterclockwise, creating the green quadrilateral A prime, B prime, C prime, D. D is the center point. It stays the same. Next, we have rotation symmetry. A figure has rotation symmetry if there is a rotation that takes the figure onto itself. But notice in parentheses there, they are telling you we don't count 0 degrees, 360 degrees, or any multiple of 360 degrees, because that results in the shape ending up right back on itself and every single point being in the exact same spot. What we want is for the figure to rotate so that the points are not in the same spot, but the image itself looks the same. So in this case, we have a hexagon. There's 6 sides to a hexagon. So 360 divided by 60 means 6. Or 360 divided by 6 gives us 60 degrees. So every time I rotate this 60 degrees, I can move the points so that they're not in the same spot, but I'm going to get an image that looks exactly the same. Symmetry. A figure has symmetry if there is a rigid transformation which takes it onto itself, not counting leaving every point where it is. So something other than rotating 360 degrees, or translating right 3 units and then translating left 3 units and just putting it right back where it was. But something like being able to reflect across a midpoint would allow it to take it onto itself. Something like taking an X and rotating it 180 degrees would put it right back on itself. That would be symmetry. Theorem. This builds on an assertion. So an assertion is when you make the statement, you believe it's true, but you've not yet taken the steps to prove it. Once you have taken those steps to prove it, then it becomes a theorem. Translation is defined using a directed line segment. So in this example, we have directed line segment T. This allows us to take point A to point A prime, creating a directed line segment A prime that is parallel to the original given line segment T, directed line segment T. Now that we've gone through the introduction, let's go ahead and take a look at the practice problems. Practice problem number 1. The figures are congruent. We have figure 1 and figure 2. Select all the sequences of transformations that would take figure 1 to figure 2. So in order to help you visualize this, I'm going to draw each step of each sequence so that we can see if it actually takes figure 1 to figure 2. But to keep the screen from getting cluttered and confusing, once I'm done drawing the steps and we see if that choice is a correct answer or not, I'm then going to erase it so that I can start fresh on the next one. So feel free to pause this video as you need to in order to make sure you understand what's going on. So for choice A, it says we're going to translate by directed line segment AD. So that means we're going to translate it down and to the right until A matches up with D. And when we do that, we're going to end up with a triangle that is right on top of figure 2. So A is in fact correct. Now let's look at option B. Rotate 180 degrees around point E. So we're going to take this figure 2 and we're going to rotate it 180 degrees. And when we do, we're going to get a triangle that is over here to the right. So all we moved was figure 2. So we definitely did not take figure 1 and put it on top of figure 2. So B would be wrong. Now let's look at option C. Translate by directed line segment AE. So if I translate by directed line segment AE, that means I'm translating it down this way. So that's going to result in a triangle right here. Next, we're going to reflect across AC. So we're going to reflect across this line right here on the bottom left of the triangle. And when I do, I'm going to create this blue triangle right here. This definitely does not put figure 1 directly on top of figure 2, so that is also incorrect. Option D. Translate by directed line segment CE. So we're going to draw a directed line segment from C to E, and that is going to create a triangle out here. The next step is to rotate 90 degrees counterclockwise around point E. So we're going to rotate 90 degrees counterclockwise, and we end up with a triangle right here where I draw this blue triangle. So clearly this blue triangle is not directly on top of figure 2, so D is also incorrect. Now we look at option E. Rotate 180 degrees around point C. So we're going to rotate this figure 180 degrees, and that will give us this red triangle out here to the left. So that's the first step. Next, we're going to translate by directed line segment CE. So we're going to take this point C, and we're going to translate it down here so that it's on top of E, and that's going to create this blue triangle down here. And now step 3, reflect across segment EF. So we're going to take this blue triangle, we're going to reflect it down, and it's going to line up right on top of figure 2. So this does, in fact, take figure 1 and put it right on top of figure 2. And option F, reflect across segment AB. So we're going to reflect across this line segment AB, and when we do, it's going to create this red triangle right here. Step 2, rotate clockwise by angle BFE using center F. So we're going to rotate clockwise, and that is going to create this blue triangle right here. And then step 3, reflect across segment EF. So we're going to reflect the blue triangle across this orange line, and it's going to create this orange triangle which lays directly on top of figure 2. So this series did in fact move figure 1 to figure 2. So F is also correct. So the correct answers on this practice problem are A, E, and F. I hope drawing these diagram steps helped you understand it better. If you still have any questions, feel free to leave a comment below. Let's move on to practice problem number 2. Practice problem number 2. Draw the image of figure ACTS after a clockwise rotation around point T using angle CTS. So that's the first step. And when we're saying angle CTS, this appears to be a 90-degree angle. So we're going to rotate it 90 degrees, and now that will give us a new shape that looks like this. And now T remains the same. This becomes C prime, this becomes A prime, and this becomes S prime. Then a translation by directed line segment CT. So the directed line segment CT is going to the right. So we're going to shift everything that same amount. So now when we shift this, we'll have a point right about here that will become T prime. This is C prime. A prime is out here now. And S prime is out here. And we can draw the shape that connects them. So if we wanted to make it easier to see, we could go ahead and erase everything from the first step. And now we have the final shape after we rotated it clockwise around T and translated it by the directed line segment CT. Number 2, Describe another sequence of transformations that will result in the same image. In this case, since we're talking about sequence, all we really need to do is reverse the previous sequence. It'll still give us the same image. So rather than rotating it first and then translating, for number 2, we can translate first, translate by directed line segment, CT, then rotate clockwise around point T using angle CTS. So this is just the opposite sequence, but we would first shift it to the right and then we would rotate it clockwise to put it into position. It doesn't matter which order we put them in, as long as we still do these 2 transformations, then we will end up with the same image. I hope this makes sense to you. If not, feel free to leave a comment below. Now let's go ahead and take a look at practice problem number 3. Practice problem number 3 will be the last practice problem of this lesson, and when we get done with it, we'll go back and we'll review the learning targets. Draw the image of triangle ABC after this sequence of rigid transformations. So just to be clear, the only part of this drawing over here that we are transforming is just the triangle part. We're not going to be doing anything to this directed line segment U. It's just there for us to be able to follow the directions with. So, number 1, reflect across line segment AB. So if this is line segment AB, then when we reflect this triangle over, we're going to end up with C prime up here, and then here is our triangle. So that's the first step. We're just reflecting across this line right here. Now, the second step tells us to translate by directed line segment U. So we're going to slide this triangle up and to the right along this line segment U. And that is now going to put A prime up here where C prime was. Then we have the line down to what will now be B prime. This line goes up to what is now C prime. And then here is the line to create the rest of the triangle. And to help you see this better, I can go ahead and erase that middle step. So this is what the final product would look like. We would translate it across AB and then slide it up to the end of that directed line segment U by translating it. So reflecting is when we flipped it, translating is when we moved it up and to the right. And then our new points are now going to be A prime, B prime, C prime. I hope this makes sense to you. If you do still have any questions, please leave a comment below. Before we finish this video, let's go ahead and revisit the learning targets for this lesson just to make sure you understand everything that you need to from this lesson before moving on to the next one. Reviewing the learning targets for Lesson 18, we had 2 of them. Learning target number 1 says that given a figure and the description of a transformation, you can draw the figure's image after the transformation. This is what we were doing in that third practice problem. They gave us a figure to start with. They gave us a description of 2 transformations, and we did the reflection first, and then we did the translation, and we were able to draw the final shape. Learning target number 2 says that you can describe a transformation that takes given points to another set of points. So this is just saying if you are given the original image or the original figure and you are given the image figure, you know how to describe how to get from one to the other. So you know how to describe the translations, you know how to describe the rotations, and you know how to describe the reflections that took place to move from that original to its image. So if you are comfortable with those 2 things, then you are exactly where you should be and ready to move into the next lesson. If you still have any questions, feel free to leave a comment below. If you found this video helpful, please give it a thumbs up. As always, please subscribe to the channel. You should see that in the lower right. In the lower left, you should see another of my videos that YouTube is recommending. And I look forward to seeing you in the next lesson.